I will now call on our first speaker, who is Michaela Aschan, who is a professor in fisheries biology at the Norwegian College of Fisheries Science in Tromsø. And Michaela's presentation, as she pulls it up on the screen, is entitled Effects of Fishing and Climate Change on Marine Ecosystems in the North Atlantic. So the floor is yours, Michaela.
Thank you very much. Good morning, ladies and gentlemen. It's a pleasure to be here today, and I want to thank the organizers for giving me this opportunity. The outline of my speech is the following. I'm going to talk about the marine ecosystems and tell you what they are like. I'm going to tell about the effects of fisheries on these ecosystems, about the effects of climate change, and also then look at the combined effects of the two. The time is short. I will just give you some cases and then go over to some conclusions. This is the marine ecosystem, a typical ecosystem in the North Atlantic. It includes the living biotic component and the non-living abiotic component in a defined area. The living part, this is the plants, the phytoplankton, the zooplankton, the fish, and microorganisms. The non-living part is the physical environment around, nutrients, currents, and so on. The arrows show the transport of energy and nutrients in this system. In some years in the north, if there is phytoplankton around, but no zooplankton around, quite a lot of this material will drop down to the benthic zone, to the bottom, provide food for the bottom organisms. While if there's plenty of zooplankton around when the plants are producing, and then quite a lot of the energy will stay up in the pelagic zone. So there's quite a variation between years. Within this system, each species have their own habitat, their own niche. This is a complex system, but it's balanced. And it's quite stable. And the marine ecosystems have the stability, the concept of stability is defined by the persistence of the system, the ability to continue without change after impact. The variability, the ability to suffer only small changes when impacted. And finally, the resilience, the ability to return to the original stage after impact ended. And we will look closer into resilience today. And to understand that, we need to know and understand the concept of trophic structure. So this is a food chain in the ecosystem, in the North Atlantic. We have the phytoplankton, the plants producing food for zooplankton. The phytoplankton are considered to be on the first trophic level. The zooplankton are the second level. We may have foraging fish on the third level and predators on the top. The man would be on the fifth level catching the fish. So, for instance, a big cod would be on the level 4, while a small juvenile cod would be probably on level 3. So, this system has different control mechanisms. If we have plenty of cod or predators on the top, they will control the fish populations like herring or capelin that will control the zooplankton. However, there is also the occurrence of a bottom-up control. And that is when the phytoplankton amount or the zooplankton amount is determining the amount of fish on the top. So there are two different controlling mechanisms, and in the northern areas we see quite a typical, the top-down control is the dominant. But unfortunately, this system is not that simple. Species are connected in a web of several connections, and a cod may be on a, not definitely on, it may be on a level, say, 3.5 in this trophic system. So, let's not make life this complicated today. We'll have mainly look at cod and shrimp today. The cod in the North Atlantic is thriving on the shelf areas around Faroe Islands, up north in the Barents Sea, on the west coast, on the west, and also in the West Atlantic. However, these stocks are not in a very good shape at the moment. The cod, one of the important predators for cod is the shrimp. And the shrimp is occurring in the same shelf areas, and there is overlap. However, the shrimp has a little bit more preference for colder water, and is also a commercially interesting species. So we'll have a look at the interactions between the two species. This is a study showing 9 different ecosystems in the North Atlantic. On the top 6 are from the Northwest Atlantic, and on the bottom, the last 3 are from the Northeast Atlantic. On the y-axis, you see the shrimp biomass. Each dot is a year studied, and in different areas there may be 10 years studied, some years even 30 years. And on the x-axis, you see the cod biomass. In general, there is a pattern showing that if there is little cod around, there will be plenty of shrimp. When the cod biomass increases, there will be less shrimp as the cod is feeding on the shrimp. This is the top-down control mechanism shown in 8 areas. However, when it gets warmer, this relationship is not that clear. This is the Gulf of Maine, south along the south in the Northwest Atlantic, and this is the Skagerrak area, south in the Northeast Atlantic, where this effect is just the opposite. And we see that with more shrimp, there is more cod, and we have a bottom-up system. But pay attention to the fact that we have a top-down control more or less throughout the whole North Atlantic. So, now we had a look at how the ecosystem is working and interacting, and we'll move over how the fisheries is influencing this ecosystem. The effects of fisheries on the ecosystem are 3 main points. The direct effect of the fishery, by removing organisms out of the ecosystem. By doing that, we reduce the biodiversity in the system. We also change the demographic structure of the species targeted as we remove the big individuals. But we also change the genetic component in the system. By removing the big ones, we also remove the genetic ability to mature